A student raises their hand in class. Which planet is hottest? The teacher smiles. Mercury. It's closest to the sun. The class writes it down. Every single one of them gets the answer wrong. Venus, the second planet, holds surface temperatures hot enough to melt lead. Around 872 degrees Fahrenheit. Hotter than Mercury. Consistently, day and night, pole to pole, without a single break. Mercury gets twice the direct sunlight. It sits right next to the sun. And it still loses. The reason rewrites everything you thought you knew about how heat actually works in space. Drop where you are watching from. And stay, because this planet has a warning inside it that concerns you directly. Start with Mercury, because understanding why it fails is what makes Venus so alarming. Mercury orbits just 58 million kilometers from the sun. During the day, its surface reaches 430 degrees Celsius. At night, the temperature collapses to negative 180 degrees Celsius. A swing of over 600 degrees between sunrise and sunset on the same planet. That collapse is the key to everything. Mercury has almost no atmosphere. Nothing surrounds it. Nothing holds the heat in. The moment the sun dips below Mercury's horizon, all that energy radiates straight back into space, vanished within hours, leaving the surface freezing by the time darkness settles. Now look at Venus. Venus orbits about 108 million kilometers from the sun, nearly twice Mercury's distance. It receives only about a quarter of the solar energy per square meter that Mercury does. Less sunlight, more distance. Every calculation says Mercury wins. Venus' surface temperature is a consistent 464 degrees Celsius day or night, equator or pole, regardless of whether the sun is overhead or on the opposite side of the planet. No variation. No cooling at night. No relief at the poles. The entire surface of Venus is one uniform furnace, burning at the same temperature everywhere, always. The reason is the atmosphere. Venus has an atmosphere 96.5% composed of carbon dioxide, 2,000 times more CO2 than Earth's atmosphere. It is 90 times denser than Earth's, equivalent to the pressure found nearly a kilometer underwater in Earth's oceans. Here is how it kills you. Sunlight passes through the clouds and hits the surface. The surface absorbs the energy and radiates it back as heat. On Earth, most of that heat escapes into space. On Venus, the carbon dioxide intercepts it, absorbs it, re-radiates it back downward. The surface heats further, radiates more. The CO2 absorbs that too. The cycle locks, and the temperature climbs until it stabilizes at the only point where a tiny fraction of heat can finally escape, 464 degrees Celsius. Venus is an extra 700 degrees Fahrenheit hotter than it would be based purely on its size and distance from the sun. The greenhouse effect accounts for nearly all of that difference. Distance from the sun tells you how much heat arrives. Atmosphere tells you how much stays. Mercury gets more heat than Venus and keeps almost none of it. Venus gets less heat than Mercury and keeps essentially all of it. That is the answer the class got wrong. But it is not the most disturbing part of this story. The most disturbing part is what Venus looked like before any of this happened. Subscribe before we go further. This next section is the part most science channels skip, and it is the reason Venus matters to you personally. Scientists long theorized that Venus formed from ingredients similar to Earth's. Venus had oceans, liquid water, covering its surface. Possibly for hundreds of millions of years. Some models suggest up to 1 billion. But Venus is closer to the sun than Earth, and receives far more sunlight. As a result, the early ocean began evaporating. That chain reaction has a name, runaway greenhouse. And the word runaway is precise. It does not mean gradual. It means self-accelerating, self-reinforcing, irreversible. The sequence went like this. Temperatures rose slightly. The ocean's surface began evaporating. More water vapor entered the atmosphere. Water vapor is itself a greenhouse gas. It trapped more heat. That trapped heat evaporated more ocean. Then came the final lock. Liquid water on the surface had kept Venus' tectonic plates moving, acting as lubrication for geological activity. Without the ocean, plate movement ground to a halt. Plate tectonics regulate carbon dioxide levels on Earth by pulling it out of the atmosphere and storing it in rock. On Venus, with no plate activity, carbon dioxide had nowhere to go. It simply accumulated, century after century, compounding the greenhouse effect with no mechanism to reverse it. The planet locked itself, and nothing has been able to unlock it in billions of years. NASA research suggests that massive volcanic eruptions may have accelerated this process, large outpourings of magma releasing enormous quantities of carbon dioxide over relatively short geological periods, possibly triggering the runaway effect that Venus could not recover from. Here is what nobody includes in the standard explanation. Venus reflects about 70% of the sunlight that hits it, making it the brightest object in the night sky after the moon. Almost featureless from space, a smooth, brilliant white sphere wrapped in impenetrable cloud cover. 70% of the sun's light bounces straight back into space. Venus barely absorbs any of it compared to Earth, and it is still the hottest planet in the solar system. The 30% that gets through the clouds is enough, held by an atmosphere so thick that even that fraction accumulates faster than it can escape. Now add the pressure. At Venus' surface, the atmospheric pressure is 93 times Earth's sea level pressure. The CO2 there behaves not as a gas but as a supercritical fluid, something between gas and liquid, corrosive, dense, moving slowly across the surface and eroding rock. The surface of Venus has volcanoes and deformed mountains. The rock behaves in some ways like peanut butter beneath the scorching temperatures, terrain with intricate patterns of ridges and grooves formed by heat so intense it warps geology itself. Every Soviet probe that landed on Venus in the 1970s and 80s, the Venera missions, survived between 23 minutes and 2 hours on the surface before being crushed and destroyed by the pressure and heat. The most durable piece of hardware humanity ever sent to another surface lasted under 2 hours. At altitudes between 50 and 65 kilometers above Venus' surface, the atmospheric pressure and temperature are nearly identical to Earth's at sea level. The upper atmosphere of Venus is the most Earth-like environment in the solar system, more similar to our conditions than the surface of Mars. A habitable zone, floating 50 kilometers above a world that would kill you in minutes. And in 2020, something unexpected was detected in those upper clouds, a chemical called phosphine, which on Earth is produced almost exclusively by biological processes. In September 2024, analysis of new telescope data confirmed the presence of phosphine in Venus' atmosphere at an altitude of 55 kilometers, at a concentration of 300 parts per billion. Here is what Venus actually is, stripped of everything else. It is Earth's rehearsal. The causes of Venus' greenhouse effect and Earth's are different. On Venus it was natural, driven by proximity to the sun and volcanic outgassing. On Earth, it is being driven by human activity. But the mechanism is identical. Venus had a habitable climate. Then carbon dioxide accumulated. The oceans evaporated. The temperatures locked at levels nothing could survive. There is no process on Venus capable of reversing what happened. No plate tectonics pulling CO2 back into rock. No rain washing carbon out of the air. No cycle that could reset the clock. Earth and Venus have roughly the same total amount of carbon. On Earth, most of it is stored in rocks, limestone, shale, coal, petroleum. On Venus, nearly all of it is in the atmosphere. That is the only difference, not the amount of carbon. Where it ended up, Venus is not a warning from another solar system. It is not a distant, alien scenario. It is the same planet as Earth, with the same ingredients, having taken a slightly different path, and arriving somewhere nothing can walk, breathe, or survive on its surface. The teacher's answer was wrong. Mercury is closer to the Sun, but closeness is not what determines heat. The atmosphere determines heat, and no feature of any planet, in this solar system or any other, is more consequential than what surrounds it. There is one place in the solar system where scientists recently confirmed conditions similar to early Venus with liquid water, geological activity, and chemical signatures that do not have a clear non-biological source. Watch that video next. It is not Mars. It is already in this solar system, and it is active right now.